Hello there and welcome to lesson 50 on statistics, specifically grouped frequency tables, and I'll also be doing a little bit about comparing sets of data. My name is Melissa Lieberman. I'm the in-house maths teacher at ICS Learn and your host for today's session. My contact details are there on the screen, so please do get in touch with me if you have any questions about anything in today's lesson. So today we're going to do some statistics. So hopefully you've watched my introduction to statistics at the end of Unit 1. And today we'll revisit some of the ideas in that, different types of average, mean, median, and mode. We'll also revisit range, but for different types of data. So data that's arranged in a frequency table, which we've also met before. I'll also take a quick look, as I said, at comparing two sets of data. To make notes if you can. If you're watching the recorded version of this, then you can pause it to make notes. If you're watching the live version, it's more important to me that you interact with what I'm saying live on screen, and maybe if you need to make notes, watch back later on if you watch the recording. A calculator will be helpful for today's lesson. It doesn't really need to be a scientific calculator, so you could even use the one on your computer, just anything that you can add, subtract, multiply, divide. So we're getting quite far into Unit 3 now. In fact, there's only one more Unit 3 lesson. So those of you who are planning to sit your exams at Foundation Tier, you just have one more lesson after today to go. Those of you doing high tier have another 16 lessons, but not to worry, 16 is a nice square number, so a nice target for you. So we're towards the end of Unit 3 now. So if you're working through your ICS Learn course materials, I'm assuming that by now you've finished test paper 2 and that you're well into Unit 3. Here is a link to the section on group frequency tables. I'll just paste that into the box now. I know I say this every time, but it's just in case somebody's watching this for the first time. If you're watching the recorded version, you can either watch, if it's a WebEx streamed version, then you can click on that link in the chat box. If the chat box isn't open, you'll need to click on view at the top, select chat, that will open up the chat box, or there's a little red icon at the top of the screen there. Click on that link and then you can go straight either to the test paper or to that activity on the ICS Learn student community on frequency tables. In the textbook, this is chapter 36 in the Foundation tier book or chapter 38 in the higher tier book. Now the higher tier book covers some more higher tier topics, cumulative frequency and interquartile range, which I won't be covering yet, but if you're doing higher tier, it might be an idea to work through that now, just so that you've studied it already by the time I go on to it in my lesson, then it's revision. So here is a direct link to the PDF of chapter 36 for you from the Foundation tier book and chapter 38 in the higher tier book. So finding mean, median, mode and range from a frequency table is mostly covered in section 1 of that chapter. Okay, so here's an overview of what I'm doing this lesson. We've met frequency tables before, but I'll just start off with the easy type and then we'll go on to the more difficult ones. So to organize data into a frequency table, we're just saying how many times something happens if it's a very easy example using tally marks. So we covered this before, but here's just a quick reminder. So supposing we weighed 16 bananas, these weights are in grams, and we put them into, this is called the raw data. So all of these numbers here, this is just the raw data. We take the bananas, we weigh each one, and we put it in, we just write down the numbers. But then we need to organize that data so that we can process it, so that we can find the averages, so we can find the range and so on. So we've got a table here. This is a typical frequency table, and it's also got a tally column. Tally is just for counting. So what we do to fill this table in, normally you would go through in order, so we'd say, okay, let me just show you how you would normally fill this in if you had a lot of data. Not everyone does it this way. You say, okay, I've got 118 here. That's a fat pen, let me just put on the thin pen. So 118, cross out 118, put a little tally mark next to 118, and then 119, cross that out, put a little tally here, 117, put a little tally here. Now, if you've got loads of data, that's probably the best way to do it. But another way, of course, is you could say, well, how many times can I see 117 in that list of numbers? And you could go through and you could count 117 in that way. But then we wouldn't really need the tallies, and you might miss some out. So that's the way that we normally fill that out. If we continue doing this for all of this data, then the finished table would look like this. If this is really easy for you, don't worry about copying this out, it's just a reminder. So each time we count it, we draw a little mark, and then the frequency tells us how many we have of each of those things. So 3 bananas weigh 117 grams, 2 bananas weigh 118 grams, and so on. Now part B says, use your table to find the most common weight for a banana in the bunch. So over to you guys watching live. Which of these bananas, or what weight of banana appears most often? Have a look at the numbers and tell me what you think. Be careful, Prajit, it's not 4. So it says the most common weight. So we've got lots of numbers here. We've got weights and we've got frequencies. The frequencies tell us how many times each thing happens. So it's quite a common mistake to write down the frequency, but we're not looking for the frequency, we're looking for the weight. Perfect, good, yes. Prajit, I think you were just going a bit too quickly there, that's fine. I'm glad you said that because it is a very common mistake. So what we're looking for is the weight with the biggest frequency. And as you can see, there are 2 weights here that appear 4 times, these ones here. So the most common weights are both 120 and 121, and this is a type of average called the mode. So we've got 2, we can have one or more number as the mode or modal weight. So the most common weights are 120 grams and 121. So these are called the modal. You'll hear mode or modal if you're using it as an adjective, the modal weights, and the mode is a type of average. Okay, so biggest frequency gives you the mode. Got it? Good. Okay. When data covers a larger range of values, then it's very common to use a group frequency table. So for example, if we're measuring lots of people's heights, it could go anywhere from, say, 150 centimeters to maybe 180 centimeters. We wouldn't have 150, 151, 152, 153, and all the numbers in between, and then say how many there were of each of these. We would group the data. So we'd say how many people are between 150 and 160, how many people are between 160 and 170, and so on, or maybe smaller than that, maybe every 5 centimeters, depending on the data. And that's called a group frequency table. It's slightly different depending on whether it's what we call discrete data. So discrete data is where you have mostly whole numbers, not numbers that are measurements. And I'll show you how the intervals look. We have met this before, so hopefully it's not a completely new idea. So for example, this is an example using discrete data. You don't need to know that language, but it's just so you've got this idea that there's discrete data, which is just whole numbers usually. Or there's continuous data, which is measurement data, where you can have whole numbers and everything in between. So here we've got a mathematics test, which has been marked out of 40. And these are the marks for 20 students. And because the marks cover quite a wide range, we're putting them in a grouped frequency table. So we've got everyone that scores between 0 and 10, everyone that scores between 11 and 20, everyone that scores between 21 and 30. Notice that it's very important not to have any overlap. So for the first category, we're going between 0 and 10. The next one, we're going between 11 and 20. Don't make the mistake of saying 0 to 10, and then the next one 10 to 20, because then 10 would be in both class intervals, they're called. So make sure that they don't overlap, and usually they'll be the same size, so they'll cover the same number of numbers in each one. Complete the group frequency table to show the marks. Iman, oh, you did the exact same question in school. They always use the same questions. It's hard to think of things that are original. Maths tests are just the ones that come into your head first when you're writing questions and you're a maths teacher. So what we do then to fill in this table is we go through the numbers, usually in order. So we say, okay, 10. So somebody got 10, that tally mark will go in that interval. Somebody got 18. That will go, and I'm just crossing them out as I go through. That will go in that interval. If somebody scored 28, so all the numbers that start with a 2 more or less will go in there. 38 will go in there. 40 will go in there. If you're watching this and you want to pause it and fill this in yourself, you can. I'm going to reveal the complete answer now. So if you go through, count them up. Very good, Michael, that's quick. Let's see if you're correct. We've got 2, 6, 5, 7. You were right. Very quick counting there. So we fill in the frequency table. Part B says, the pass mark for this test was 21 out of 40. How many students passed the test? So we look at our numbers. We don't need to use the ones in this section anymore. We can just look at them here. So now that they've been processed, it's a little bit quicker to go through and work out the answer that we need. And what we need is everyone who is in these two categories here. So everyone that scored between 21 and 40 will be the sum of these two numbers here. Add them together. Well done, everyone's got it right. We're starting nice and easy today. This is much easier than previous lessons that we've had in recent times. So not too taxing. It will get more complicated when we start looking at averages for group frequency tables, but this is a nice gentle start for you today. So 12, perfect, good. Now, it's a little bit more difficult if we're just given the table and we're not given the raw data, the actual original numbers, because somebody's already processed it, so we're kind of losing a little bit of information. So let's see what happens when we have that. Now, be careful with the numbers because there's lots of numbers in here, and be aware of what this table is showing you. So in this particular example, we've got a frequency table of mobile phones owned by number of people. So what this is telling you is number of mobile phones 0. So 4 people have no phones. 1 person has, 9 people have 1 phone, 5 people have 2 phones, and 2 people have 3 phones. So it's always a good idea to say, okay, what are these numbers showing me, just so that you don't get mixed up between the frequencies and the number of phones. Part A says, find the modal number of phones owned. Let's have a look at the table and tell me the modal number of phones owned. Remember, modal is another word for mode, and mode means the one that appears most often. So we're looking for the number of phones with the highest frequency. Dorina, be careful, don't fall into the trap of putting 9. 9 is the number of people that have 1 phone. So the modal number of phones owned is not 9. That's the frequency. So always be careful when you're asked to put you fall into the same trap as error, which I'm really glad that you said that, because it's a very, very common error. So think carefully about what it is that it's asking you. The modal number of phones owned is 1, because that's the one that has the highest frequency. So most of the people in this group have just 1 phone. 9 people have just 1 phone. So the modal number of phones owned is 1. Okay, easy mistake. I'm glad that you've made it, because that allows me to highlight that point. I would hate it if everyone watching was a math genius, and then I wouldn't be able to explain things. Right, part B. What is the median number of phones owned? It's a little bit trickier. Have a little think about it. So what that means is, remember, the median is the middle value from an ordered list. How am I going to do that? I haven't got an ordered list here. So if I wrote all of the number of phones owned by each person in order, don't worry, Kiki, if you're late, you can watch the recording, see what you've missed. How do I find the median? Any ideas? A good way of thinking of it is say, okay, I don't have the raw data here, but I can get an idea for it, because I know that 4 people have no phones. So if I were writing these out in order, I would have 0, 0, 0, 0, 4 of them. And then 1 would appear 9 times in my list. So we're kind of doing it backwards. So instead of taking the data that we started with and then putting it in the table, we're taking the data in the table and putting it back out again. And we would have, if we were doing the survey and asking people on the street, how many phones do you have? How many phones do you have? How many phones do you have? 9 people say 1. So I'd have 1, 1, 1, 1, 1, 1, 1, 1, 1, 9 times. And then how many people would say 2? 5 people would say 2. So I would have 2, 2, 2, 2, 2. And then 2 people would say 3, 3, 3. See? So by thinking of it that way, you can get all of your original list of numbers. There are how many people altogether? Well, 4 plus 9 plus 5 plus 2 is 20. So there are 20 people in our survey. If I wrote all of the number of phones that each of those 20 people had in order, the middle value, the median, would be halfway between the 10th number and the 11th number. So let's have a look at what that looks like. You don't have to write out all of these numbers. It's just a way. I just want you to think about what's happening here. With practice, you'll be able to go through and add up the numbers to get an idea of the value that you're looking for. So if we wrote out all of the numbers of phones that each person had, that's what it would look like. There's 20 values. So the middle value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think it's those 2 there. They're both 1, so that makes it easy. The median is going to be 1. Normally, if the numbers were different, you would add them together and divide by 2 to find out what's halfway between them. So the middle value is 1. Now, if you want to do it without writing out all of the numbers in order like this, the way to do it would be to say, okay, there are 20 people in this group, and I know that the median is going to be halfway between the 10s and the 11s, and I would just add up the numbers. So 4 people have none. 4 plus 9 is 13. So I know that between the 5th person and the 13th person, they've all said 1. So the median then is the 10th and the 11th value is going to be 1. So that would give me that answer as well. So what I would do is I would go through and add the frequencies until I got to the middle value, and that would then tell me the median number of phones. Okay, so you can see how this is getting a little bit tricky once we have it in this kind of frequency table. So if you want to, you can write 10th value plus the 11th value divided by 2. They're both 1, so the answer is going to be 1. Okay, happy with that? Okay, how about part C? This one you have to think about a little bit. Make sure you use the number of phones and not the frequencies. What is the range of mobile phones owned? Now remember, the range tells us it's not an average, it tells us how spread out the data items are. So to find the range, what we need to do is take the biggest number of phones owned and subtract the smallest number of phones owned, and that will tell us the range of those values. We've got some different numbers appearing here. Some people think 3, some 2, some 7. So the most number of phones owned is 3. So that's the biggest number of phones owned, and the smallest number of phones owned is 0, none at all. So the range, to get the range, we need to subtract 3 and 0. Don't subtract the frequencies. We don't need the frequencies here. We just want to know the range, and we're looking at the number of phones owned. So it's very easy with these, I understand it's very easy with these kinds of tables to confuse what the frequency is and what the number of items is. So just be careful with that and keep saying to you, what does this table show me? What does this table show me? And then you should get it right. Okay, so this is what this looks like. The largest value minus the smallest value. And by value, I mean the number of mobile phones and not the range. So this is the biggest value here, and this is the smallest value here. So the range of the numbers is between 3 and 0. So the range is 3. Is that okay for that one? Perfect, very good. Okay, happy with that? I mean, if you think about it, it just wouldn't make sense to subtract the frequencies, because I could ask a million people, and I would have a very big range indeed then if I was using the frequencies. So what I want to know is the range of the number of mobile phones owned. Okay. Now, sorry, got a bit of a sore throat. Here's the same table again. I've kind of answered part A in the last question, so if you want to type it in the screen there, you can. So this frequency table, again, shows the number of mobile phones owned by a group of people. We're just going to use the same table again. How many people were there in the group altogether? So remember, to find the total number of people in the group, if it doesn't tell us in the question, we just add together the frequencies. 4 plus 9 plus 5 plus 2, thank you, Ikra, gives us 20 people altogether. Now part B says, what is the total number of mobile phones owned by this group? What we're trying to do in this question is find the mean number of phones owned. We don't have the original data. Remember, to find the mean, we have to add together all of the numbers and then divide by how many there are. Now we could write our big long list of numbers like we did in the previous question and then just add them all up. 0 plus 0 plus 0 plus 0, plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, plus 2 plus 2 plus 2 plus 3, and so on. But there's a quicker way of doing that, because we can use multiplication, can't we, to add up all of those numbers. So if we were asking all of these 20 people how many phones they had, then we were going to add up how many phones they had all together. And then, so 20 people, right? Take your phones, put them all in this bucket, and then divide by how many people there are. That's how we would find the mean. So what we would do with this kind of frequency table, rather than going through and adding all the numbers, we multiply. So to find out the number of phones in the 0 category, we can say 0 times 4, which is just 0. So those 4 people each have no phones, so together they have no phones. Then 9 people have 1 phone. So 9 times 1 is 9. So those 9 people who only have 1 phone between them have 9 phones. And then we've got 5 people with 2 phones. 5 times 2 is 10. So those 5 people together have got 10 phones. And then we've also got 2 people who've got 3 phones. So those 2 people together have 6 phones. So by multiplying through, if you want, you can put an extra row on your table. That's a good idea. Now it might be a row or it might be a column. It just depends how your table is organized. And we multiply the number of phones by the frequency. We can then work out the total number of phones, and that will then allow us to work out the mean number of phones. So if we add these up, 9 plus 10 plus 6, that will tell us the total number of phones. So 0 plus 9 plus 6, very good. And John Paul, you've gone one step further, fantastic. 25. So 20 people altogether, they own 25 phones. So the mean number of phones owned is 25 divided by 20. Perfect. And everyone that's put 1.5, that's correct. So 25 over 20. If you don't have a calculator, you can write it as a fraction and cancel those down. You would get 1 and 1 1/5, I think. Yep. No, 1 1/4. Sorry. 25 divided by 20, 1.25 phones. Good. Right. Now, what happens when we have class intervals? So here we know 4 people have got exactly no phones, 9 people have got exactly 1 phone, and so on. But what happens with those tables where we've got the data in intervals? Things get a little bit tricky. So grouped frequency table, remember, is where our categories cover a range of values. So we don't just have, so supposing we were doing a different, I can't think of an example off the top of my head, so I'll just show you one. In the case where the data has been put into a grouped frequency table, we can't find the mean exactly. We have to estimate the mean because the data has been processed and we don't know what the original values are. If we need to find the median from a group frequency table, then we're going to say which group it lies in. We can't say the exact value either. And similarly, we would find the modal interval rather than the actual value. So when it's a group frequency table, the mean, median, and mode is just a little bit more of an estimate. It's a bit rougher. You can find the range because you can just take the highest interval and the lowest interval and subtract the largest and the smallest value. So that's fine. So here's test results for 20 people. Can't remember if that's the same data that I used earlier on. And these have been put in intervals. So 2 people scored between 0 and 5. 3 people scored between 6 and 10, 6 people scored between 11 and 15, and so on. But we don't know the actual marks, so we're going to have to estimate the 3 types of averages, more or less, or it's just going to be a little bit vaguer. So part A, write down the modal group. So within which of these groups do most of the test results fall? So here we just look for the one with the biggest frequency. Perfect, Rob. Anyone think that it's anything else? I've just said perfect, so sorry, I've kind of given away the answer then. So we look at the frequencies and we say, right, the biggest frequency is 11. Sorry, I don't know where I got. I was looking at the class interval. So the biggest frequency is 6. So that means that the modal group is between 11 and 15. So most of these 20 students in this class scored between 11 and 15. So that's the modal group there, 11 to 15. Which group contains the median? Anyone like to hazard a guess? So what we're going to have to do is we say, right, we know that there's 20 people. We don't have their raw scores. If we had all of their raw scores and we put them all in order of size, then the median value would be between the 10th and the 11th value. But we don't have that. So how can we work it out? So the easiest way, I think, is to do a kind of a running total. We know that it's between the 10th person and the 11th person. So I've got 2 people in the first group. 2 plus 3 is 5. So what I'm doing here is something called cumulative frequency. You don't need to know this for foundation tier, but it's just a way of finding where this 10th person is. So 5 people score between 0 and 10. Then if I add on 6, I've got 11. So that means that 11 people must get between 0 and 15 marks. And those 10th and 11th persons must fall into this category. It's quite common for the modal group and the median because they're both just different types of average to fall into the same category. So here we've got the same answer. It's not always the same answer, so watch out. So yes, the category that contains the 10th and the 11th person must be the score of 11 to 15. Good. Have you got that? 11 to 15. And then part C, let's find an estimate for the mean. Now we can't work out the exact mean because these 2 people that score between 0 and 5, we don't know if they got 0, 1, 2, 3, 4, or 5. So what we say is, okay, let's say they got 2.5 marks. So what we say is we find the midpoint of 0 and 5. So halfway between 0 and 5, 5 plus 0 is 5 divided by 2 is 2.5. So halfway between 0 and 5 is 2.5. So what we do is we do a kind of an average for each of the categories and we find the midpoint like this. halfway between 6 and 10 is 8. To find that halfway point, we do 6 plus 10, which is 16, divided by 2 is 8. So what we then say is, okay, 2 people, let's just say that those 2 people scored 2.5, because that's halfway between 0 and 5. And then let's say that the next 3 people scored 8, because that's halfway between 6 and 10. And then let's say that the next 6 people scored, I'm just trying to quickly work out what's halfway between 11 and 15, 13 marks, because that's halfway between 11 and 15. And in this way, by writing the middle number in each of these intervals, we can estimate what the mean would be. So we're kind of doing the average of each interval and then multiplying it by how many people got that mark. Because there's a few steps here, and we usually add another row onto our table, or column, depending on how the table's orientated. I'm just going to move on to another slide because I can't fit it into this space here. So let's have a look at this. So we're going to find the midpoint for each group. So it's usually called the midpoint. Sometimes it's called the mid-interval value. Usually the numbers are easy enough that you can probably just work out the middle value without doing it this way. But the way so it's very similar when we found out the mid values for coordinates. So the way you find halfway between 2 numbers is to add the numbers together and divide by 2. So the middle of 0 and 5 is 2.5, as we mentioned briefly. Halfway between 6 and 10, 6 plus 10 is 16, divided by 2 gives us 8. Halfway between 11 and 15, we'll add 11 and 15 together, divide by 2, we get 13. Halfway between 16 and 20 is 18. Halfway between 21 and 25 is 23. And halfway between 26 and 30 is 28. So if you like, these numbers are like the average score in each of these intervals. So to work out the total score for each of those people, we need to then multiply by the frequency. So 2 people got an average of 2.5. So those 2 people altogether, 2 times 2.5 is 5. So then we're going to multiply the midpoint by the frequency. So frequency times midpoint, put another row onto your table. 2 times 2.5 is 5. 3 times 8, and we put that in there. 3 times 8 is 24. 6 times 13, put that in there. Sorry, 24. 6 times 13. This is where you're going to need your calculator, perhaps. Maybe you could do that in your head, but I would probably be reaching for my calculator by this point. 78. 4 times 18 is 72. 4 times 23 is 92. And 1 times 28. So this last person who scored between 26 and 30, I don't know whether they got 26 or 30, so I'm going to say, okay, they got 28. There's only one of them, that's their score. So this is the equivalent of what we're trying to do, remember, is add up the scores of everyone in the class. If I had the raw data, I had the 20 numbers, I could just add them all together to find the mean, but I don't, so this is why it's an estimated mean. And then the last step would be to add all of those numbers together. That would give me the total score for all of the students, and then divide by how many students there are. I'm just going to pause the video. I need a little drink. Just a moment. Okay, anyone worked it out yet? So add all of those numbers together. There is a lot of steps, and I'll be showing you a sample exam style question in a moment just to show you how to set it out. So we add up all of these numbers. So the 5 plus 24 plus 78 plus 72 plus 92 plus 28 tells us the total of all of the scores. Strictly speaking, I suppose this should say estimated mean. Because it's not the exact mean, it's just an estimate. So what we do is the top number, we add them all together. We divide by how many people there are. Now I know I've added all the frequencies there, but we're told in the question that there are 20 people. So really you could just put 20 on the bottom, but it's always a good idea to check by adding all the frequencies together. That tells us the total number of people. What do we get? 299 divided by 20. It's not going to be an exact number. 14.95. Remember, this is just an estimate anyway, so to 2 decimal places is absolutely fine. There's a lot of steps, and this does come up at Foundations here. Let's have a look. This is from edXL's sample assessment materials for GCSE 9 to 1. This is question 27 on the foundation tier paper, but the exact same question is on the higher tier paper. Remember that the grade 4 and 5 questions on the foundation tier exam papers are repeated towards the beginning of the higher tier paper. So what you'll find is those same questions, grade 4 and 5 questions, are common to both higher and foundation tier. So here's a very typical exam style question. And the table shows some information about the foot length of 20 adults. Part A is easy enough. Write down the modal class interval. So remember, for that we're looking for, it doesn't say frequency in this table, but the number of adults is the frequency. So we're looking for the one with the most number of people in it. Part A, 1 mark, or 1 whole mark. What is the answer? So what we're looking for, it's not 12, be very careful, amen? 12 is the biggest number of people, but we're looking for the modal class interval. The class interval is, let me just change colour, the class interval is this bit here. So if you write 12, you won't get any marks. That's the frequency. The frequency tells you which, so we're looking for the biggest frequency, but the modal class interval is the one with the biggest frequency, so that you then need to look along on the table. So the modal class interval is between 22 and 24. Okay, very, very common mistake. I think 3 or 4 people have made the exact same mistake, so please learn from this and know that it's not the frequency that you need to put in for the modal class interval, it's the class interval. Remember, this range of values is called a class interval. Perfect. So the actual answer is F between 22 and 24, and that's the number that you need to write on the answer line. Okay, 1 mark for that. Part B says, calculate an estimate for the mean foot length. Now, there's quite a lot of work involved here, but as long as you're systematic and work through it, should be okay. It's worth 3 marks. What I would do is add an extra column to the table. Add an extra column like this. And I would call that column midpoint. I would work out the midpoint of each of those foot lengths. We've got the frequencies already, and then maybe you could add another column again here. And then this last column, what you want, I hope I'm going to fit it in, is midpoint times frequency, which we're going to work out next. And I knew that would probably go outside the scope of my table. So you've got space on the exam sheet. Just add in 2 more columns. I've not done it here in my written solutions, but because I was using a computer, I can make it quite neat. So find the midpoint, multiply the midpoint by the frequency, which remember is the number of adults. Then you've got your total. Add up the totals, and then that will give you the mean foot length. So what we're doing is, these are 40 adults. We haven't got the raw data. We need to add up the lengths of all of their feet. Is the greater than oh yes, that is a typo. Yeah, sorry, you're quite right. That one there, well spotted. I think I was just on autopilot. I probably cut and pasted that symbol because I had to go and find it. Yes, that symbol should just be less than or equal to. Not sure if you would lose a mark if you didn't copy the interval right. You probably still get full marks for that if you hadn't copied out the interval correctly. You wouldn't get any marks for 12. But I think if you wrote one of those symbols incorrectly with an equals instead of not an equals, you would get the marks. Okay, so let's work out part B. So what I would do is I need to find the midpoint for each interval and multiply it by the frequency. It doesn't matter what order you do it in, whether you find the midpoint first and then the frequency and then multiply them out. I've done it like this. Now the midpoint for each of these intervals is quite easy. I'm not going to do 16 plus 18 and then add them together, because I know that halfway between 16 and 18 is 17. I know that halfway between 18 and 20 is 19, and so on, because there's only a gap of 2 between each of these ranges. So if it's quite easy, just write it straight in. So if it was between 10 and 20, you know that halfway between 10 and 20 is 15. So if you can work it out easily in your head, then just do it that way. So the midpoint between 16 and 18 is 17. So 3 people have a shoe size of about 17. So altogether that's 51. So these 3 people, always imagine what it is that you're working out. These 3 people have got shoe size of between, foot length of between 16 and 18 centimeters. So I'm saying, okay, well, let's just say that their foot length is about 17. So 3 times 17, 51. How about the next one? Yeah, so if it's between 2 numbers, you take the halfway point. The next one, halfway between 18 and 20 is 19. So we're going to work out 6 times 19. So if we're adding up all of the lengths of all of the feet of those 6 people, and all of their feet are about 19 centimeters long. Multiply that by 6, we get 114. Perfect, man, good, 114. How about the next one? You should be able to do that in your head without a calculator. Halfway between 20 and 22 is 21. And about 10 people, not about, exactly 10 people have got feet length of about 21 centimeters. So we do 10 times 21. What we're doing is we're adding up the lengths of all of the feet of those 10 people. Sounds like some great deed, their feet, by 21, and we get 210. Halfway between 22 and 24, 23. 23 times 12, 276. Halfway between 24 and 26, 25. 25 times 9, 225. Okay, 1 mark for that. A lot of work for 1 mark, isn't it? Now, what we want is the total foot length. So to work out the total foot length of all of these people, we need to add all of these numbers together. 51 plus 114 plus 210 plus 276 plus 225. On your calculator, what do you get? Sorry, John Paul, they don't, because I'm not sure what you're saying about the greater than and equal to. Don't worry about that. We're just talking about the range of values. So with continuous data, you do need to use these greater than and less than signs. All it means is that for the first category, this is everyone between 16 and 18, not including 18. For the next category, it's everyone between 18 and 20, not including 20. So it's just that we include every possible value without any kind of overlap. So when it's continuous data, it needs to be categorized like this using these greater than and equal to symbols. And it just means that foot length, sorry, F between 18, just means it's between those 2 values. Does that make sense? Okay, anyone got the total yet? Oh, some people are coming up with an answer. Very good. So let's have a look. So if we add up all of those numbers, 876. We need to divide by the total number of adults. We are told in the question that there are 40 adults, but if you want to just double check, add all of the frequencies together, add all of the number of adults together, we get 40. So to find the mean, or the estimated mean, we need to divide the total foot length, there we go, our estimated total foot length by the number of people, 40, and that will give us the answer there. So 876 divided by 40, 21.9. Perfect. And that's how you estimate the mean from a grouped frequency table. Probably come up in the exam on one of the 3 papers, I would have thought. So have some practice of that. Now we've got a little bit of time left, and I didn't cover this topic previously, so I'm just going to squeeze it in here. One thing I didn't get time to cover, so if you want to do it from the textbook, is misleading graphs. Might come up in the exam, but I just didn't have time to cover it in this lesson, and it might be in foundation tier. But if you want to have a look at some misleading graphs, have a look at section 2 in chapter, I can't remember the name of the chapter now, was it chapter 37? Have a look at section 2, and that covers misleading graphs. So very quickly, let's have a look at how we compare 2 sets of data, and then I'll give you some time to go away and practice some questions. So when we're asked to compare 2 sets of data, it means a very specific thing in maths. What they expect you to do is to compare the average for the 2 sets of data. That will either be the mean or the median, depending on the type of data that is, and will often be given to you, or you'll calculate it in a previous part of the question. Excuse me. And the range. So remember, these are 2 different things. Average is a single number that is typical of the group of data, and the range is how spread out it is, or how consistent it is. So if it's a very big range, it's less consistent. If it's a very small range, it's more consistent. So that's what range is telling us. It's a measure of spread. Then we need to look at the 2 sets. Which one's higher on average, which one's lower on average, which one has a bigger range, which one has a smaller range. And it's literally as simple as that. You just take the numbers and you say, this one's higher, this one's lower, and maybe interpret it in the context of the data given. So here's an example. So I'm going back to Tess. So the teacher in me, so I have to think of an example as easy to do tests. But this time we've got spelling test, not math test. So 2 sets of children sat a spelling test, and here are their scores out of 20. So we've got two sets of data here. We've got set 1, and these are the scores of the first set. They scored out of 20. The 20 doesn't really matter. It doesn't come into the calculation. So set 1. 5 children, and they scored 12, 13, 12, 11, 14. Set 2, they scored 15, 12, 19, 10 and 18, and we're asked to compare the two sets of data. So what does that mean? We've got some numbers on the top and some numbers on the bottom. To compare them, we need to calculate the mean for both sets, and we need to calculate the range for both sets to get full marks. And then we need to make a written comment to say how those two compare. So first of all, let's work out the mean. Remember, that's the one where we add all the numbers together and divide by how many there are for set 1. So the mean for set 1, try it on your calculator now, but if you add all of those numbers up, you get 62. There are 5 numbers there altogether, so divide by 5. 62 divided by 5. Oh no, that's fine. You were helping Claire, that's okay. I must have missed a question, I was so busy talking there. Gives us 12.4. Okay, so the mean for set 1, the mean score is 12.4. And what's the range for set 1? Well, all we have to do is subtract the smallest number from the biggest number. So that would be 14, subtract 11, 3. So the range, perfect, Iman, is 3. How about set 2? So again, we're going to find the mean for set 2. Add all of the numbers up, divide by 5, 74 divided by 5, 14.8. So we can say something now. We can say that on average, set 2 has higher scores than set 1. What does the range tell us? Well, let's work out the range. The biggest score, so they've got bigger scores, but say, look, someone here got 10, which is actually lower than, so although their scores are higher on average, somebody got less, but the average has carried it up. So they're a lot more spread out, aren't they? So we're expecting that the range is going to be a lot bigger. So the range for set 2 is 19, take away 10. 19 subtract 10 is 9. So these are much more spread out. They're much less consistent, less predictable, shall we say. So when we make the comment, we need to say, first of all, this is the easy one, on average, set 2 scored higher on the test, or you could say on average, set 1 scored lower on the test. Both mean the same thing. For range, try and include this word consistent. Examiners really like it. So if you're talking about range, use the word consistent, and you know that you'll be interpreting the data in the right way. So the set 2 is much less consistent because the range is bigger. Set 3 is much more consistent, much more predictable because it covers a smaller range of values. Sorry, I'm just saying you don't know where your brain is. Don't worry at all. 9 was right. So the second statement I would make regarding the range would be that the results for set 1 have a lower range, so they were more consistent. So smaller range, more consistent, bigger range, less consistent. So similarly, you could also make the statement that set 2, so you could say something like, on average, set 2 scored higher on the test, so they were better on average, but they were much less consistent because the range was bigger. Okay with that, there's an exercise there in the textbook if you want some extra practice, but that's basically what they're asking you when they're asking you to compare 2 sets of data. Just realised I left off an S there. 2 sets of data. Sorry. No one's spell checking for me. Oh, okay. If you want some videos, I think that the most important thing to learn from this lesson is how to find the estimated mean from a group frequency table. Take a little bit of practice. There's some good Hegarty maths videos if you want to watch them. One's a revision video where he goes through some past paper questions, so that will be quite useful. What I would do when I'm watching these videos is I would look at the question, pause the video, try the question, and then watch the video for the answer, and that way you'll be getting a lot more practice than just passively sitting and watching someone else work it out. You might want to watch them work it out for the first one, but then if you're actually answering the question yourself, you're much more likely to learn the method. Please use this MathGenie website. It's really good, mathgenie.co.uk/GCSE. This topic is in the grade 4 section. Yeah, if he does talk a little bit quickly, just press pause. So I probably talk too slowly, I think, because I don't know how I managed to talk about maths for an hour in each of my lessons. But they're quick. So if they're quick, just press pause. You've got the pause button there on the video. Press rewind. It's a great thing about video lessons is you don't have to watch them in real time, unlike in a real classroom. You can pause them, you can rewind them, you can watch them again. It's a fantastic resource. So if you're doing the questions on MathGenie, These are all in order of grade, so scroll down here until you see averages from frequency tables. I'll give you the direct link. If you click on revision, you get a revision video, and if you click on averages from frequency tables, you get some exam style questions, and then you get some written solutions. So if you're really bogged down and in a hurry and you do nothing else on this course, watch my lessons and then work through the practice questions on Math Genie or Mathed Up. Mathed Up is for the old ABCDE course, so that's why I'm now referring you to Math Genie, because they've reordered their materials to match with the 9 to 1 grades. So do these, even if you don't have time to do the textbook. I'll give you the links here. So this is the page with all of their GCSE resources. Similarly, the Hegarty Maths is still written for the old course, so you might get some topics that say higher tier that are now foundation tier, but this is new. So there's the Maths Genie page. To watch the Maths Genie revision video, they've got a couple of videos for averages for frequency tables. So if you just want a quick revision video, watch these, there's a link. And if you want the exam style practice questions, if you don't want to scroll down, these are actually the same GCSE maths takeaway questions that are on the Mathed Up website, sheet number 79, but you can download them from this table. So there's the questions and the answers. So it might be an idea for these ones to print out those questions unless you're really trying to save paper, because then you'll get the tables and you can add in the midpoints, and then you can multiply by the frequency and so on to work out these answers. So there we go. I know a lot of you are still using Maths Buster. There's two sections in here, frequency tables and averages, and group frequency tables and averages. So make sure you have a look at that and try some of their questions. We're kind of edging into grade 5 territory here, so you're doing well. Now, oh sorry, let me just give you the link if you want to use Maths Buster for your revision. Here's the link if you want to have a look at it online. It does cost $12.99, but you get so much for that $12.99. You get all of the revision notes, you get videos for every single topic. I don't work for CGP, by the way. I just think it's a really good resource. If you did have some money to spend and wanted to get something to help you with your revision, I would try Maths Buster. If you're doing higher tier, I will go back to quartiles, interquartile range, box plots, and cumulative frequency, which is covered in that chapter there, on the 9th of May, if you're watching me live. And next lesson, this will be the last lesson in study unit 3. So once you've completed that last lesson, you can try test paper 3. Those of you doing foundation tier can stop there, and those of you doing higher tier will then move on to study unit 4. Okay, that's everything from me for today. Are there any questions before I let you go? Okay, I know I'm well under an hour today, but it'll make up for the ones where I went quite a lot over earlier in the unit. If you need help with anything, please don't hesitate to get in touch or contact your tutor. If it's something that's nothing to do with maths, contact ICS Learn Student Services, and I will see you next lesson for probability. So next lesson, probability, will involve Venn diagrams, and probability trees are also new to foundation tier, and that will be the last topic for the unit 3 and those of you studying higher tier. Foundation tier, sorry, excuse me. Enjoy the rest of your day, and I'll see you next time. Bye-bye.